Hi, welcome. You probably learned about arithmetic sequences and series at school today and you're a little confused. Don't worry, I'm here to help. First, we'll talk about arithmetic sequences. And basically, if we talk about the word itself, arithmetic sequences, and we break it down, sequences mean a set of numbers that progress in a consistent way. And if we say arithmetic sequences, that just means that the change between the two numbers are an addition of a certain number. So I'll get more into how that works in this example a bit later, but we'll talk about the general formula first. So un is equal to u1 plus n minus 1 times d. And that's just a bunch of random letters to you at this point, but that's okay. First of all, u1 means the first term within the sequence. So in this case, it would be 1, right? This is the first term. And d denotes the number that is added to every change. And so this is usually referred to as the common difference, hence the letter D. And un basically means the number within the sequence of that order. So it's a bit confusing, but n is basically the order of the number within the sequence. So if we take a look at 13 over here, within this sequence, then 13 would be u4 because it's the fourth term in the sequence. So that way, n really denotes the order of where the number is within the sequence. And this n is the exact same. So, for example, if we look at this sequence, we know that u1 is going to be 1 because it's the first term, right? And we look at the common difference. The common difference, basically, if you're dealing with an arithmetic sequence, the change between 1 and 5 and the change between 5 and 9 will be the same. And it will be one consistent number. It can be a fraction. It's not necessarily always an integer, but it will always be consistent. And that's why the common difference is written as a letter. And in this case, you see from 1 and 5, the common difference is 4. And between 5 and 9, the common difference is 4. And the same goes on until the end. So we can tell that the common difference is actually 4 in this sequence. And now, since we have u1 and d, we can write the general form of this sequence, this specific sequence. And that would give you u1 is equal to 1 plus n minus 1 times 4. And you can leave it like this, but sometimes it's a little simpler if you expand this bracket and simplify it. So it'll be 1 plus 4n minus 4, and that would give you minus, well, let's write the 4 first, 4n minus 3. And that would be the general formula of this sequence. And say you wanted to find the 10th term of the sequence, because you're not given the 10th term, you're just given until the 6th term. So if you talk about the 10th term, you can find the term in the sequence because you know the general formula. And you just need to plug in n to the formula because you've already simplified it. And that would give you 40 minus 3, which is equal to 37, u10. So that's how arithmetic sequences work. So the difference between a sequence and a series is very essential to remember. The sequence is just the set of numbers. This is a sequence. The series is the sum of all the numbers up until the term that's denoted. So up until n, basically. So the general term would be Sn, which is the sum of all the terms up until the nth term, is equal to n over 2 times 2u1 plus n minus 1 d. All these formulas are in your formula booklet, by the way, so if you're having a hard time remembering, you can always refer back to it, but it's really handy to just know these. So if we look at the example here, the example sequence, this is the same one as just now, 1, 5, 9, 13, 17, 21. And if we look at S4, it's basically asking for every number, the sum of every number up until the fourth term. Basically, that means that we're looking for 1 plus 5 plus 9 plus 13. And that is what S4 is. But up until 4, it's quite manageable, obviously, because we know all the numbers. But if we get to S10, we won't know the 10th term. We won't know the 7th, 8th, and 9th term to add all of those. So we use this formula. And so if we put in 10, if we substitute n as 10, as well as u1 and d, we can get the sum of all the terms. And that would give you 5. 2 plus 9 times 4 is 36, and 2 plus 36 is 38, and 5 times 38. This will just be 5 times 38. You can put that in the calculator and you'll get the answer. Alternatively, you can use this other formula. And this is a little easier. It just depends on what kind of information you're given. So if you're given S4 to compute, then you can use this formula because you know un, right? Because we're given access, if we say S4 is equal to 4 over 2, u1 is 1, plus u4 is 13, right? And so since we're given the exact value, we can use this formula. And it's much easier and it's much simpler. And we'll get 2 times 14, right? Just for the sake of proving it, 6 is 19 and is 28, right? 2 times 14 is also 28. So these two are the same. And so the formula is quite useful when you're given the right information, but if you're not given un, just like for S10 here, we're not given the 10th term, then you kind of have to use this. And this formula applies more broadly, which is why you should probably remember this and not this, really. We'll try a common type of question that you will get from arithmetic sequences and series. This question states that the third term of an arithmetic sequence is minus 8, and the sum of the first 10 terms of the sequence is minus 230. Find the first term of the sequence and the sum of the first 13 terms. Straight away, we know that we should be using both un and sn, and it's dealing with both the sequence and the series because it's talking about the sum of the first 13 terms. But let's tackle part A first. So, the most important thing in these word problems is to put them in terms of variables. So, say the third term of an arithmetic sequence is minus 8. You can write that as u3 is equal to minus 8. Right? And similarly, it says the sum, when it says the sum of the first 10 terms of the sequence is minus 230, you can write that as the S10 is minus 230. And now you're asked to find the first term of the sequence, and you might be going, whoa, where do we get u1, right? But it makes a little more sense when you expand u3 and S10. And if we do that, according to these formulas, then you'll get u1 plus 3 minus 1 d times d is equal to minus 8. And the same thing here. So now we're given these more elaborate equations. And from this, we can tell that we have two variables and we have two equations. So basically, we can solve for both the variables. So if we simplify both sides a little bit so it makes it easier to see, it becomes u1 plus 2d is equal to minus 8. And this becomes 5. 2u1 plus 9d is equal to minus 230. We can divide 230 by 5, so we'll do that. And now, the equations are a lot more easier to work with. Here we can see that we could isolate u1 and make it so that it's equal to minus 8 minus 2d, and plug u1 into this equation. and that gives us 2 times minus 8 minus 2d plus 9d is equal to minus 46. From here, it's just computation and basic algebra. You get minus 16 minus 4d plus 9d is equal to minus 46. This becomes 5d, and this becomes minus 30, and then d becomes minus 6. We plug in d back into here, minus 8 minus 2 times minus 6. u1 is equal to minus 8 plus 12, and that gives you 4. So u1 is equal to 4, and that's the answer to the first part, right? So now that we found both u1 and d, we can kind of easily find the sum of the first 13 terms, and that's just substituting n as 13. And so part B, S13 would equal 13 minus over 2 times 2 u1, we already found that from the last part, plus 13 minus 1 times d, which is minus 6. And all you gotta do is expand this and compute this. You can actually just put all this into the calculator if you're lazy to calculate it. 8 plus, this is 12, equal to 520. So that's the answer for part B. So the key thing to remember is that you need to get all the kind of conceptual things correct. The calculations are merely just, you can have calculation errors, right? But most of the points that you'll get on your exams and stuff will be from this first step, or your steps, and how you apply the formulas to a word problem. Right, and that's the most important thing. And the way I solved part A is a very prime example of this, because you don't actually have to get the final answer to know that you understand. I mean, it's correct to check if you're right and if you're doing it correctly, but as long as you're putting in the right numbers and you're interpreting the question in the right way, you should be fine answering these questions. So just remember, arithmetic sequences are just a set of numbers that progress with the addition of a common difference, right? And the series is basically the sum of all the numbers up until the nth term. That's the main difference. After this, you'll probably learn geometric sequences and series, which is the same concept, but now it's not a common difference, it's a common ratio. And it basically means that the way the numbers progress is not by the addition of a number, but the multiplication of a number. So we'll get into that in another video, but hopefully this helped. If you have any questions, you can leave it in the comments. I will be responding. And if you have any other topics that you want me to cover in math, physics, and chemistry for IB, you can leave it in the comments as well. I am also a student, so I might not have covered the topic yet, but I will try my best to explain that topic to the best of my abilities. So hope it helped. Thanks for watching.